This whole environment, this IRI Workbench front end that was also supposed to drive the NextForm operations to source COBOL and take you out to flat or a database, is this same environment where you can do other things. With respect to that, including test data synthesis, if you just have a DDL about a database and you needed to mock up a prototype to experiment with things, we can do that. And also data masking as well, if there is information that's sensitive, those are also built-in functions into the language. But that language is what you saw, I think, before, which manifests in these sorts of scripts. So here's a script that takes data that is in a flat file, tab delimited in this case, sorts it on 4 keys, and then pumps it out to a couple of different files, which could be the fodder, a pre-sorted load file into BCP. You can take these fields, right-click, create database load file right from there. Pick BCP, for example, and it would produce that. Then you could string that process, this sort in the BCP, into what we call a workflow, which is this sort of a diagram. This operation, which manifests in a batch script, which looks like this. We produce the batch script too, but you run the batch script basically, and it runs the sorts. And if there were subsequent BCP statements, they would be in the same batch. You'd be sorting, you'd be cleaning, and you'd be loading all in one batch. This represents 4 tables. Here you have a delimited input. Here's another input, which is in CSV. So this is tab delimited. This is comma delimited with a header. There's a sorting and a join going on here also. And the big difference also is when we do our transformations, we don't use, unlike SSIS, we don't use the database to do them. We have our own C language executable that runs externally and doesn't tax the database to churn all this stuff. But anyway, you can see the mapping going on from input to output. The first one here is fixed position. So we've gone from delimited to fixed. It's just a question of, we use field names, that's a symbolic reference for the mapping. So as long as you use the same names, as you go from input to output, the program understands that, and then it remaps them as you see fit. So here's another example where you're remapping the same information in the fields and taking it to an XML definition. This one's appending a bunch of HTML encoding around it to format a web report. So it's a very flexible language based on that very notion of source to target mapping on field names. Those job scripts also manifest in these SSIS, I assume, like ETL diagrams, if people prefer a more visual representation of the job. We can also play with it this way. And there's also dialogue representations of it too.
That's how it's intended to work. It's actually about a 2 megabyte runtime engine called sortcl.exe, and it does have a couple of DLLs that it'll load if it needs to do things like ODBC or certain transforms, but it's a real small runtime. You could integrate it with SSIS or any other process control type system that runs batches. You can put it in batch files, shell scripts. It's cross-platform. Those same job scripts will run on both Windows, Unix, Linux, as long as you pay a little attention to the file naming conventions. The way it's intended to work, this is really a design time environment more than a runtime, but you can run the jobs from here to debug them and look at sample output and everything. But once you have the job debugged, runs and works, you don't need to edit it anymore. It can be scheduled either through this tool or from any. Basically, we'll create a folder that has all the scripts in it and either a batch file or a shell script that runs them in the order they need to run in if order is important. And then that whole folder can be zipped up and moved somewhere else and executed with a command line or from any program that can execute a system call. If the whole point is to get it all into one database eventually, what your real constraint is how fast can you write to that database? How fast is the pipe going into that database? If you were to stage into multiple staging databases, you've still got that final step where you have load all that stage data into your one primary database. And that's going to be, as long as you had everything right, if you just went ahead and loaded it right into that master database, then you had to spend to stage it to all those staging databases, because we operate at IO speed. There's not that much processing that's going on. It's a little bit of text manipulation, a little bit of buffer manipulation. It's not a lot. Typically, unless you have very fast IO, I don't know what your network fabric looks like, but we're usually blocked on IO. We're usually waiting either to read the next buffer off the disk or to write it to the database, one or the other. It's not like it's CPU intensive. It's just IO intensive. So what becomes the limiting factor in how fast you can get all of your data into your primary database is how fast can you write data? How big is the pipe between wherever you're processing the data and the database? And if you make that pipe as fat and high capacity as possible, that's the fastest way to get your data in, because it's not like this is CPU intensive. What you want to do, if you want to test it in Azure, you probably want to set up a virtual machine in Azure and do a native installation of our software on there, and we can get you a 30-day trial license.
We'd walk you through it. Basically, you'd start out an empty slate. None of these projects on the top left would be here. None of these database connections would be here, but those are not, it's just a question of creating the project. Click IRI new project, and it creates a folder. And
setting up your ODBC and JDBC drivers,
that's
your SQL Server database, and that's pretty easy. We've made it easier than it used to be because we wrote a bunch of the Eclipse database stuff to basically work right. It was kind of a neglected thing with Eclipse, so we finally kind of took that over and fixed a lot of the bugs in there. So it's pretty easy to do.
the benefit of connecting to the database through this interface is to not just see the tables and work with them, but also leverage all the functionality that's associated with what we can do at these different levels. So you can see I can right click on the schema and get this sort of information. You can right click on one or more tables selected, and these kind of options that are part
And especially if you're wanting to do something like go from a fixed position to a delimited or put it into a database, there's going to be certain, like the trim, where you want to trim the data. You're not putting string values into your database that have a whole bunch of trailing space or leading space on them. You can write kind of rules for that. It's an actual function in our domain specific language in those job scripts, but you can write a rule, assign it to a whole bunch of different types of column, or as we call fields, in a flat file. Then when you generate a whole bunch of scripts automatically through the wizards, it'll automatically apply those rules. So it'll create those scripts for you with those functions and with those conversions from fixed position to delimited, creating the necessary commands in there to put the data into ODBC. So you can generate a whole bunch of these job scripts once you've just imported all the metadata from your flat files, from your table structure. I don't know if you already have your table structure all worked out. If not, we also have tooling in here that will look at, if you just define the metadata for your flat files, we can actually create the DDL, to create table statements necessary to create tables that match that flat file structure. What you'd want to do before you started your job script creation, you'd want to go ahead and take that DDL that the Micro Focus or whatever tool it is you're using generates, and go ahead and create your empty database structure so that you have that available, because then we can scrape that metadata out of the database. We can scrape the metadata for the flat files, probably artifacts from that as well. We have some COBOL conversion utilities, so you should be able to automate most of that metadata conversion based on what's coming out of that tool.
The GUI is there to automate the definition of these field layouts in our syntax from your existing flat files that we can parse. If they're delimited, our parser will pick up the delimiter and spit out this information like this. If it's fixed, there's a sort of a hand parser that's in the GUI to facilitate that, just in a different way, but you get the same result.
If you got a copybook, we can convert that.
It depends on how simple they are. Would help a lot of them, but also we can parse the DDL information from here. As Don said before, you can either generate DDL or you can parse it and produce our DDF from it. See? So DDL to DDF and DDF to DDL, or DDF to BCP file. But DDF is the data definition format that we use. That's what we call it. We call it DDF, and SQL calls their stuff DL, but it's all metadata that maps back and forth automatically. Just so you know, we call this platform Voracity. It's just another licensing sort of scheme. There's the CoSort product, which is the traditional, the very first thing we've ever, and that's what's still the most widely used product that we have. And this is the original menu and workbench to support co-sort job scripts, which is all you'd need really for the sorting stuff. This enables the filtering too and the reporting. These wizards are input, output, input, sort, output, basically with other capabilities for mapping options. But other wizards, if you were to have this whole Voracity tool, would give you other things like the ability to mask what's in your flat files or your databases if anything's sensitive, you want to discover that information, classify it if you're worried about compliance with the privacy law, for example, or a breach mitigation strategy. There's whole ETL functionality, so this is a la SSIS, right? But with our engine instead of using SQL Server, which is 10 times slower in volume. So we would just do the same capabilities. These wizards subsetting is also possible if you wanted to work with smaller database subsets one day. It could also be masked. There's this whole facility for generating relational schema with tables full of test data that's structurally and referentially correct. And flat files too. You can create all kinds of test files from scratch. And there's other tooling in here too if you ever get to work with unstructured data one day. This is migration and replication and stuff. So there's a whole set of tooling that's enabled from an ergonomic standpoint in this same GUI. And at the end of the day, most of those things just produce scripts like this anyway that just do different things. It's a more flexible option if you were to say, well, I just need the COSRT utility. That's fine. We can sort of sell you that if you want it. Or you can sort of license this whole giant infrastructure built around it to do a bunch of other things with data and different sources. But the main value add is the speed and volume. So happily you have volume, and flat files are our sweet spot, so it should be a nice match.